Okay, class, we're at the very end of the document, and the last thing we're talking about is the motor endplate potential. The motor endplate potential. Okay, let's go back. Here is skeletal muscle. Each of these are muscle cells. Here's a neuron coming out and synapsing on the skeletal muscle cell, forming a neuromuscular junction. Okay? So we have a presynaptic and postsynaptic. Here is that neuromuscular junction right here. Neuromuscular junction. Okay, so let's start with this. The motor endplate on a skeletal muscle cell is the area of the cell reserved for the synapse of the motor neuron, somatic motor neuron. So this would be, so the motor endplate is on the skeletal muscle. If we pop this off, it's that space reserved for this neuromuscular junction. It is at this site that the neuromuscular junction is formed. It's at this site that the neurotransmitter substance, acetylcholine, is released. Okay? So let's see how this works. We're going to use this drawing over here. We'll use this drawing over here. Okay. So what will happen is, let me see if I can reach this and blow it up some. All right. Action potentials come down. Action potentials come down. The action potentials coming down using the usual sodium and potassium voltage pendant gates come across here. Now we do see calcium. Here there are calcium channels. We said at the synaptic end bulb, calcium channels, right? The voltage of the action potential causes the calcium channels to open. Calcium is in higher concentration outside the cell than inside. The calcium rushes in and causes the synaptic vesicles to come down. The synaptic vesicles then fuse with the membrane. Once they fuse with the membrane, and the synaptic vesicles in this case, since this is a neuromuscular junction, okay, contain acetylcholine. That's the neurotransmitter. Once they fuse, by the process of exocytosis, they release this acetylcholine into here. Now, to operate one of these on muscle, I need 2 acetylcholine molecules per receptor. 2 per receptor. Here are the receptors, which have specificity and affinity. The receptors then pick up the acetylcholine, 2 of them, and that causes the opening of ligand-gated channels. The ligand-gated channels opening then will give me a motor endplate potential. A motor endplate potential. All right. Now, the ligand-gated channels, what do? They allow both sodium and potassium to move. Sodium moves in with a stronger force, remember, because of the electrochemical gradient, then potassium moves out. So ultimately, enough sodium moves in to cause this membrane to reach threshold. Adjacent to that are voltage-dependent gates here. And so that motor endplate potential, which is very similar, let's go back, which even though it's called a motor endplate potential, is very similar to the EPSP, making the inside more positive to reach threshold. In this case, to reach threshold in a muscle cell. When you reach threshold, as I alluded to, action potentials occur. Then the action potentials move away in all directions. But when we get back to, when we start talking on muscle, the action potentials move along the membrane, but they also move into these things. Now, this is a muscle discussion called the T-tubules. The T-tubules then release calcium. Now, this calcium's inside the cell, and this is for contraction. This is for contraction. Okay? So I'm kind of tending into another subject here, even though this is electrophysiology. Now, the next point is this real quick, and then we're going to read this. How do you get rid of the acetylcholine? Now, we'll be bringing this up again in other lectures. This is more of a generic on electrophysiology. The acetylcholine is broken down by enzymes that are present in this membrane, and the enzyme is called acetylcholine esterase. See here, this enzymatic degradation? Acetylcholine esterase breaks it down. So how do you get rid of the neurotransmitter? As they said, some just diffuses away. Because remember, this is a moving stream. But some gets broken down by an enzyme here called acetylcholine esterase. You'll be reading on that. And that'll break acetylcholine down into acetate plus choline. Okay? The acetate is swept away. The choline can be resucked back up to reform some more acetylcholine. But that's another subject at another time in another chapter. So let's go here. The motor endplate we just talked about. The motor endplate is similar to the EPSP in neurons. It is not an action potential, but rather a graded potential that involves the opening of ligand-gated channels. The acetylcholine causes the opening of channels to both sodium and potassium, but due to the stronger driving force of sodium, which we mentioned, more of it comes in, causing the membrane to move to threshold. This allows adjacent voltage-dependent gates along the skeletal muscle cell to open, initiating action potentials, which propagate in both directions all along. So they're going to go in both directions, but they are going to meet eventually. Think about it. They go in both directions, and actually in multiple directions. If it was 3D, multiple directions, they're going to meet on the other side eventually. Do they stop or keep going? No, they stop because of the absolute refractory period we mentioned. So we're hitting a lot of stuff here now. The action potentials then will go into, so these actions then travel along the membrane and into the T tubules, causing the release of calcium ions from the terminus cisternae. This is another subject which gets us into muscle. This starts the mechanical event. See, muscle has two major events. Now listen to me. Neurons only had one. They only did, conductivity, excitation. But muscle has to do two things. Has two major events, excitation and contraction. The excitation is the charge event. That's all that charge stuff we've been talking about in this electrophysiology. Okay? The contraction is a mechanical event. The events must be coupled. Contraction does not occur without excitation. So you got to have the excitation to get the contraction. So the buzzword that you'll see in books, in this book and other books, is EC coupling. EC coupling. Excitation, contraction, coupling. Excitation, contraction, coupling. And certain conditions and drugs can cause the two events to uncouple. All right. Now let me explain. We have not done everything in looking at electrophysiology. You can again look at my other PowerPoints. But as we get into the chapter of muscle, and as we get into the chapter of nerve tissue, we'll add some more. But it will not be as difficult as this, because if you get this down, then the other will come quite easy. This resting membrane potential and action potential is one of the harder subjects. The other is just using it. The other didactic information is just using it. So try to study hard on this and get a good feeling for it. Also look at a couple of videos I'm going to put in, not my videos, but some motion videos, and let's get that thing going. All right. Thank you very much.